Read the question carefully. Here we are trying to see if this function is continuous at this x value. Okay, here at 0, here at 1. If it is not continuous, then we need to state the type of discontinuity. So here this is the fixed x value 3. If we plug in 3 here, we get 1 over 3 minus 3 is 0. 1 over 0 is undefined. That means this function f is discontinuous at 3. So we can say discontinuous at 3. Now we need to determine the type. Generally when we get 1 over 0, that's undefined, but that will be most of the time going to positive infinity, negative infinity, or one side negative infinity and the other side positive infinity. But to determine, we can take the limits, one-sided limits, or we can graph. For me, this, I think easiest way would be graph. Graph this function 1 over x minus 3. Then we get a graph something like this. So we have a vertical asymptote here, and this will be going to negative infinity, and on the other side is positive infinity. So the function goes to infinity. So the type of discontinuity is infinite discontinuity. Okay. In part B, in second question, we have absolute value involved. Generally, when absolute value is involved, we need to find one-sided limits, because we know absolute value of x is defined in this way. This will be absolute value of x is x if x is non-negative. But if this is negative, less than 0, negative, that means this is already negative. If we write just x, that's wrong because it's negative, so we have to put negative. Okay, in the case when x is less than 0. So using this definition, we get two outputs. So we need to take, when we find the limit, we need to find one-sided limits. And clearly when x is 0, is a fixed point of x, 0, when we put 0 here on the bottom, we have 0 over 0, or it's indeterminate, okay, it's undefined. We cannot divide by 0. So obviously discontinuous at 0. To determine the type, let's find the one-sided limits. Limit of this function when x approaches to 0 from left, and simultaneously let me do the following: limit 0 going from right side of this function. That is when x goes to 0 from left, means x is less than 0. Okay, so the function is absolute x over x, and when x is less than 0, look at here, absolute value is negative x. So this is negative x over, we have x on the bottom. Okay, x cancel, so negative 1. Okay, and for this right hand limit, x approaches to 0 from right side, means x is bigger than 0. So when x is bigger than 0, absolutely x is just x. So in this case, this function is just 0 from right side. Absolutely x is just x over x. So 1. Look, that means negative 1 and 1. That means the function, the limit of the function at 0 does not exist. For a function to be continuous, we have to have three things. The function should be defined at 0. See, when we plug in 0 here, 0 over 0, this is already undefined. Okay, and then that should be it. It's undefined, so discontinuous. But to determine the type, look at here, we found one-sided limits and they are not the same. So there is a jump. So jump discontinuity. Okay, there is a jump from negative 1 to 1. And finally, this third question. So let me is here and finish. Like 1 and 2, when we plug in x value, a equals 1 here, 1 minus 1 0, so we are dividing by 0. That means this is discontinuous at 1. Okay, looks like the top factors. Let's look at here. Okay, we can simplify, or if we take the limit at 1, this factors is x plus 1, x minus 1 over x minus 1, cancel, plug in 1, so 2. At least the limit exists. Okay, that means at 1 the graph has a hole, limit exists. Okay, that means the graph has a hole. Or if there is a cancellation like this, you don't have to even find the limit. You can say there is a hole, that means removable discontinuity. Okay, final.